Solving using factoring. As an introduction, I'd like you to look at these problems and see if you can solve them. And the only hint I'll give you is do not multiply them out. Leave them as is and see if you can figure out what the solutions to each one are. Stop the video while you work, give it a shot, and then we'll restart the video when you're ready. Okay, were you able to solve them? Let's take a look at the solutions. X minus 1 times x minus 2 equals 0. The solutions are 1 and 2. Second one would be the solutions negative 3 and 9. Third one would be 8 and 725. And the fourth one would be 0 and negative 7. Looking at those solutions and the problems next to each other, can you see the easy way to work them? Okay, the goals of this lesson are to introduce you to the zero product property, something you've maybe used for years but never gave it a name. We're also going to look at what the factored form of a polynomial is, and then I'll do several examples of solving by factoring. The zero product property says that if you multiply two things together and the result is 0, then one of the two things must have been 0. More formally, if a times b equals 0, then either a equals 0 or b equals 0, and in math speak, it could be both. Now, to solve in factored form, you need to find values of x that make one factor 0. You can see in the first example below, x minus 1 times x minus 2, that if x is 1, 1 minus 1 is 0. The second factor is 1 minus 2, negative 1, but 0 times anything is equal to 0. In the second example, you can see that negative 3 will make the first factor equal to 0, and 9 will make the second factor equal to 0. So both negative 3 and 9 would be solutions to that equation. So if an equation is not in factored form, like this, and you need to solve it, putting it in factored form might be the thing to do. So let's see what factored form is. So the factored form of a polynomial is when the polynomial is written as the product of factors rather than in standard form. So if we look at the equation, the first equation, x squared plus 3x plus 2 equals 0, factored form is x plus 1 times x plus 2 equals 0. And for the second one, if you factored that, 3x plus 2 times x plus 1 would be the two factors. Now this one is a little bit different. There's no constant term, but you can still factor into 5x times x minus 4. And as long as you can factor a variable out, that will give you a clue as to how to solve the problem. Now this equation, the one on the left, is not quite in standard form. In order to factor this and in order to make using the zero product property work, the right-hand side of the equation has to be equal to 0. So before continuing, you would need to add 10 to each side of this equation. Then it would be x squared plus 10x plus 25, and then you can put it in factored form, x plus 5 squared equals 0. And this equation, x squared minus 4, doesn't have an x term, but it's a difference of squares, so it can be factored, in this case, as x minus 2 times x plus 2. Solving by factoring simply means rewriting the polynomial on the left-hand side of the equation in factored form so that you can use the zero product property to solve this. Now note that this only works when it is possible to factor the polynomial, and if you can't factor it, there are other ways of solving, but this won't work. So this only works when the left-hand side can be factored. So let's take a look at this problem. We can indeed factor x squared minus 8x minus 20 into x minus 10 times x plus 2 equals 0. We can see easily that the solutions are 10 and negative 2. And let's check them just to be sure. If x equals 10, then we put 10 in both places, the first x and the second x, so we get 10 minus 10 times 10 plus 2, which is 0 times 12, which is indeed 0. And if we check negative 2 as a solution, we put negative 2 minus 10, that's negative 12, and negative 2 plus 2 is 0. So that's negative 12 times 0, and that is also 0. So those two solutions work. Here's another example. X squared minus 6x minus 55 equals 0. So first we factor, and this indeed can be factored. And then we can see easily that the solutions are 11 and negative 5. And then we can check them. First with 11. 11 minus 11 times 11 plus 5. That is the same thing as 0 times 16, which does indeed equal 0. And with negative 5 minus 11 times negative 5 plus 5, that's negative 16 times 0, and that is also 0. So these two solutions work. Next, this problem. Now notice that it is not quite in the right form. We need to write this so that the right-hand side of the equation is 0. So we will need to add 32 to each side to put the equation in standard form for a quadratic equation. And then we can factor to x plus 6 times x plus 7. And we can find the solutions easily as negative 6 and negative 7. And then we can check the solutions as we did before to see that both of them work. In this example, we see that 6x squared minus x equals 2 is not in standard form. The right-hand side does not equal 0, so we do need to make that happen as our first step. So we subtract 2 from each side. And then we can factor this polynomial to 2x plus 1 times 3x minus 2 equals 0. And then we can see that the solutions are negative 1/2 and 2/3. Now, if it's a little bit hard for you to see that those are the solutions, here's how you can approach that. You need to find first a value of x that makes 2x plus 1 equal 0. Well, we can write an equation for that. 2x plus 1 equals 0. And if you solve the equation, it's pretty simple to solve. You can find that x equals negative 1/2. And you can do the same thing with the second factor, 3x minus 2. Set 3x minus 2 equal to 0. Solve, and you can see that x equals 2/3. So if you get factors that are not simple x plus 1 or x minus 2 or something like that, this is one way that you can find the correct solutions. Okay, number 5. So in this one, there's no x term. So what do we do? Well, this one happens to be a difference of squares. So we can factor this as a difference of squares to 3x minus 7 times 3x plus 7 equals 0. And then find that the solutions are 7/3 and negative 7/3. And we can check the first solution, 7/3, and see that it works. And then the check for negative 7/3 is just the same. I'd like you to give these problems a shot. Please stop the video, work out the solutions to all of them, and then restart the video to see the solutions. Okay, let's take a look at the solutions. And there they are. The first one, it can be factored into x plus 4 times x plus 7 equals 0. And the solutions are x equals 4 or x equals negative 4 or x equals negative 7. For the second one, you need to subtract 50 from each side before factoring. And then you get x squared plus 2x minus 48. And that can be factored into x minus 6 times x plus 8. And then the solutions are 6 and x minus 8. The third one can be factored into 2x minus 7 times x plus 5. And you can see that the solutions there are 7 halves and negative 5. Problem number 4 is not in standard form, so we need to subtract 71 from each side. So then we get x squared minus 81. That factors to x minus 9 times x plus 9. And you can see that x equals plus or minus 9.